Hey guys, Martin here with my own two hands and another project. And I'm still in my workshop, but I'm surrounded by electronics development equipment, which you are not used to see here. But yeah, I do this kind of stuff also from time to time. And I also have in front of me this black box. It is actually a device which has been handed to me with a notion that it doesn't work, and if I'm interested in fixing this. And the description of the problem and the box cannot be more vague than this, because this is supposed to be a device which you connect to a computer, and you connect some analog sensors to it through this set of connectors. And it sort of does some kind of measuring, I guess. Well, it's sensor related, so yeah. The program for this device is written in for MS-DOS, so that's another thing that you cannot run that easily now. And yeah, all of this is old, probably like 15 to 20 years, and it is custom made for the company, and there is no documentation whatsoever. So this will be a sort of mystery, finding the mystery of this device, learning how it works and why it doesn't work, because that's another thing which is fairly vague, and that's the description of the error, because it is being said that it works and sometimes it doesn't work. So that's the best possible description I'm able to get. And yeah, that's what we have to work with. So let's do some visual assessment first. So it is a plastic box. It is this enclosure is sort of a universal enclosure for all sorts of electronics. So if you have some electronic device and you want to give it some enclosure, you can go with this. It is two parts. It has two parts. One part is on the top, the other part mirrored is on the bottom, and you have the front and back panel, which just is squeezed in these grooves. And on the front panel we have two LED indicators. One is green one, and it is marked as power, and this one is yellow or orange, and it says measurement. It doesn't say anything else. There is some beat up logos. It's called SAME4, maybe SAME in Czech, and this is what it is. It looks like a rubber. Oh, it's just a rubber feet. Okay, so let's put that back. I don't know what that's for, but probably for nothing. And at the back we have 8 connectors. These are called DIN connectors. So it's not exactly any normal designation, but we call it a 5-pin DIN connector. And this has been widely used many years ago for analog equipment. Like if you want to connect the turntable to an amplifier, there is a high chance that it has been connected by these connectors in past. And there is this Canon 9 connector, and the label doesn't show any description, but I would guess that this is for the computer. And Canon 9 connectors have been widely used for the RS-232, the serial port. So that's probably how the communication works. And that tells me basically that there is some low voltage circuitry, probably mixed with some digital integrated circuits. So that gives me an idea of what voltage I should expect inside. So that's something around 5 volts. That's the most common for integrated circuits. But for analog circuitry, and especially for amplifiers, because the signal from the sensors will be low, and it has to be amplified in order to measure it and put it out on the through the serial port. So I would think something like 5 volts should be inside, and maybe something higher like 12 volts, maybe 15 volts, something like that. And if the sensors are, for example, they give out an AC signal that revolves around the zero volts, 2 plus and minus, there should be a source of negative voltage as well. So maybe there will be something like plus or minus 12 volts. We will see if it will be necessary. The weight of the device, it is like around 1 kilogram, I guess, 2 pounds. And that gives me an idea that the power source will be probably a transformer, which is a device made out of copper coils, and they are significantly heavy, and it is like a left side heavy. That means there is something heavier in this part. And yeah, there's the cable. The cable is a standard 230 volts, but it doesn't have the ground pin, and that leads me to an idea that there is some level of ground insulation from the mains voltage, and that would call for the transformer, which is the natural isolator. And by the age of this device, I would say that the power section is made out of the transformer and probably some linear voltage regulators, because back then it wasn't cheap to have switching power supplies. So yeah, should we power it? There is no button for powering. It's just cable and the power LED. So let's try to power it up. Okay, so the power is on, and there was short blink from the measurement. Maybe that's just some initial calibration, and yeah, by the look of it, it should work. So the idea of device working and not working at the same time is most probably there is some bad cable, that this lead, this power cable is probably twisted and broken inside. So the first thing I'm going to do is to just push on the cable and see if this LED will turn off. Okay, that looks, maybe. Okay, so it looked like that directly at the plug there was a problem, but it doesn't, no, it's okay, but it definitely went down for a bit. Okay, maybe if I will pull this. No, okay. So it doesn't seem to be the cable issue. Let's do something else. Let's give it a good tappy tap. Okay, the measuring just went. Okay. And it's dead. So it looks like there is some mechanical issue inside. Maybe some cold solder joint, maybe there's some connector inside which is not properly pulled in. So yeah, let's open it up. I will unplug this, always unplug the devices. So what do we have here? We have 4 screws. There are some additional screws, but these are much likely to be holding the printed circuit board inside. There will be some standoffs, so this is the place to go through that. And yeah, we have, it's good PZ. Okay, that's a nice good old technology. So this is the transformer, and it is almost directly connected to the 230 volts, and the cable is luckily it has some ring that prevents to be pulled, but there is a heavy soldering on the PCB side. I'm not sure if you can see it, and I have this microscope, so I should be able to show you these things more directly. Do you see? So there is a lot of flux going on, so that doesn't look very nice, and you can see how the body of the transformer is scorched just a little bit, but that's not a problem. The coil of the transformer is hidden inside pretty well. So we are going to check what type of transformer it is. It is 220 volts at 50 to 60 hertz. That's a normal thing in Central Europe. And there are two secondary coils. One is for, how much is that? It's for 12 volts and it gives out 125 milliamps. So there are two coils, and that would call for the symmetrical voltage. So down there in the power section, which is clearly this thing, the other thing, these black centipedes, those are the integrated circuits, and that's where the logic and the measuring is happening, and this part is clearly the power section. So it takes 230 volts AC, and somehow through these linear regulators, I will look at them later, they give out the low voltage, something like 5, 12, 15 volts to the rest of the circuits. So let's see, it's 12 volts, so I would say that these regulators should be something like LM7812 and 7912. Let's see, and it is 7815. Okay, that's a interesting thing. And there's no designation, no visible designation on the other. Oh, it is 7915. Okay, so this gives out the symmetrical voltage. You have plus 15 and minus 15 volts, which is probably for some amplifiers that they are trying to bump up the signal to this level, and then it can be measured by some measuring circuitry inside. There is also one small regulator, and it is 78L05. That's a linear voltage regulator. It takes roughly 25 volts on the output, on the input, 25 volts DC, and it turns it into 5 volts. And it is small one. This one is in a small package, which means that it can give out only small current, something like 100 milliamps. The big ones, the beefy ones, in the TO220 package, they can give out up to 1.5 amperes, which clearly isn't needed by this circuitry, but maybe it is needed and given out to on the connectors to the sensors. Who knows? So let's check the power LED. One way to do the power indication is to connect it directly to the voltage, some regulated voltage. The other thing, the other way is to give this indication to the further circuitry, because the further circuitry can do some sort of a boot up, some sort of a peripheral checkup, if we are talking about microcontrollers and this more complicated stuff, maybe with some programming and so on. But this is a fairly simple analog circuit, so there is nothing, no peripheral checkups, no booting of operating system, no running of any code of sorts. So it is probably the easiest way is to connect it directly to the to some voltage inside. And that means that the power indicator doesn't say anything about the functionality of the circuitry, but rather the presence of the voltage. So what we can do is to power this up carefully, because there is 230 volts inside, and I can do, and if I will have it in the state of non-working, then I can measure where the voltages are and try to find out the cold solder joint. So let's plug this up. The green light is not working, so we can check. I will start with the 230 volts and just be sure that it is in the correct position. Okay, and let's measure this thing. There is 230 volts. It goes not quite logically through this fuse, so let's check there. It is 220 or 230. It is even here. Okay. Interesting thing happens. If I will push on this fuse, it will go up. So maybe it's just a bad fuse. So what we can do, or what we have to do, is to pull up the circuit board and check from the underside. So I have freed up the PCB, and let's check the underside. Okay, it's fairly nicely done. These big traces are for some common ground. Here is the power section because it is flipped, and we can see that this is a really botched job. Okay, this is interesting. So this is the trace from the line voltage. It goes to this through hole, but there is drilled another hole next to it, and it just crudely soldered together. And it is most probably because the designer of this circuit board didn't measure this distance properly and just made a mistake. So let's try to fix that, shall we? I don't have a good fix, and I don't even have a workaround for this. Maybe I will use some wire that I can solder to this trace, so it is much longer and it helps at more spaces or more places than the original one, and I can do the same thing here, but that's pretty much what I can do. I really don't like the way how these solder joints look like, so maybe I will do them once more. They are very crudely done, so let's fix both of these things. Let's make this shorter. Okay, and let's heat this up and put some additional solder to it. There is a void here, so I will use that void. I'm using 300 degrees Celsius. Okay, now it's catching. Okay, that looks much better, even though I still don't like it. That really looks dreadful, but yeah, I hope it will work. I think it will work. It holds in there quite nicely. Now, what about this? I'm thinking just taking some wires, laying them on the traces, and just extending the trace to the joint. Okay, that will look really crude, but maybe more functional. Let's see. I just need to take it. The problem with this soldering connection, especially on the transformer, is that the transformer is heavy. So if you push this device around, the most heavy component will do something inside. So that's probably the problem, and maybe we will have some fix for that. So I would say that it probably is finished. It doesn't look that nice. Let me wipe this down with some alcohol. Does it go off? Yes, it does go off. Okay, so now I can carefully plug it in. I will take the green LED. Let's put it into the socket with the white facing the white mark, just like that. Let's bend it so we can see it, and it should go green. It is green. And now if I will push on the same place I was pushing, it looks more sturdy. Okay. Yeah, I would call this a fix. Bad one, but still a fix. Okay, we can check the voltages, I hope. So let's measure DC voltage, and let's find out the common ground. There is a nice pin. This is a test pin. Okay, and here I think I should measure something like a minus 15 volts. And it is exactly minus 15. And here should be plus 15. Yes, it is. And here it should be plus 5. Now it's still plus 15, so why? Okay, I get it. Here, yes, plus 5. Okay, so the voltages are correct. So I would say that this is a good fix. Device didn't work. Sometimes didn't work, okay. But the device didn't work, and now it works. And let's pull one corner and just flex the PCB so any of these cold solder joints are stressed, and be extremely careful not to short out anything. But it looks very nice indeed. So let's power this off, let's put it inside the box, and hopefully it will work the same way. Okay, let's give it a test before I will close this. Okay, green one is greening. Let's do a little push here and there. All right. Let's call it a fix, shall we? Well, I don't have way how to test this. I will give it back to the company so they can test it with the sensors and with the computer and with everything, so they can let me know. But yeah, that was a pretty obvious problem on the circuit board, and it just needed a little bit of solder here and there. And let's see if it will work for another 15 to 20 years. Okay guys, Maybe this wasn't the most exciting video, but it was own two hands job nonetheless. And let's do something else, shall we? There is something underneath that table that needs finishing. That will be next week's video. Bye!